Okay, this is lesson 1.3, and we're going to talk about sets. And basically, set is a collection of objects of, we'll call this set S. S is a set, and P is an object, written as P is an element of set S, or P is an element of S, or P belongs to S. A lot of times you'll see in other videos where they'll use P belongs to S, but I like to use P as an element of set S. Okay, union is sets S1 and S sub 2. If sets S, we have sets S sub 1 and S sub 2, then set S1 is a union of S2. That means that all objects in both sets are included in the union. The intersection of set S sub 1 intersects with set S sub 2. Only objects that are in both sets that are in common would be included in the intersection. So we have set S sub 1 is a union of set S sub 2, union ... continues on, set S sub 3, union with S sub 4, union with S sub 5, and so on. Union with S sub n, where n is a natural number for union of set S in n number of sets. We have S sub 1, S sub 2, and S sub n. Then S consists of all elements in each of the sets, of which at least one of the n sets, so that there's at least one element in each of the sets that are in the union of all the sets. So here we have S is a set is equal to the union of I equal 1 to n for S sub I, union of n sets. So that again, that would equal this would equal union S sub 1, union S sub 2, union S sub 3, union S sub 4, union union S sub n. Okay, so union is also refers to or, meaning elements in one set or the other, whereas intersection means and, it has to be in both sets. So S equals to the intersection of I equal 1 to n for S sub I, so that'd be S sub 1 intersection S sub 2 intersection S sub 3 intersection S sub 4 intersection S sub 5 ... intersecting with S sub n. The intersection of n sets, S1, S2, S3, S4, and so on, S sub n. So that's S would be the intersection of each of the sets intersected together. Well, what would that look like? If you had S1, S2, and S3, you may see something like this. So the intersection would be something that holds all three, if you look at it like in a Venn diagram. Okay, an empty set is the intersection with no elements in common of the two sets. So you would call these disjoint sets. Empty set for disjoint sets would be an example of real numbers and the intersection of real numbers and the alphabet. Nothing in common in those two sets. So it would be an empty set. Okay, set of all even integers. We have the curly bracket indicating a set. All elements in set X such that X equal to 2 times n, and n is an integer. So you'd have 2 times 1 is 2, 2 times 3, 2 is 4, 2 times 3 is 6, and so on. So each, no matter what n is, you're going to get an even number. So we've created a set of even numbers that way, where x is the generic element of the set. Okay, here is a set of rational numbers. Rational numbers meaning like fractions, integer over an integer, in the open interval from 0 to 1, open 0, open at 1, and all numbers in between. So we're talking about all fractions or all decimals in between there. So all elements in set x such that x is an element of the open interval between 0 and 1, and x is a rational number. Okay, here we have an example of a set, -2, 0, 1, the set whose elements are in the numbers are the numbers -2, 0, 1. Okay, union, property A or property B. Property A and the set having is the union of the set having property A and the set having property B. So if we're looking at this, the set of all elements in the set X such that X has property A or property B would be equivalent to the set of all elements in set X such that X has property A. Close the set, union, open set, X, all elements in set X such that X has property B. So again, you're using the union for property A and property B. And here we're looking at intersection. The set consisting of both property A and property B. X has property A and property B. So here X has property A intersection. X has property B. Okay, subset. A and B are two elements, and everything in set A is also in set B. Then A is a subset of set B. So the first term is always the subset to the second term. So an example of a subset would be natural numbers, counting numbers, 1, 2, 3, and so on, is a subset of whole numbers. Well, whole numbers start with 0, and natural numbers only start with 1. So you could say natural numbers is a subset of whole numbers. A equals B implies A is a subset of B and B is a subset of A. You could say set A is A, E, I, O, U, and sometimes Y. Set B are vowels. So you could say A is a subset of B, which it is, and B is a subset of A, so A and B, A, E, I, O, U, is equal and set to the set of vowels. Okay, next we're going to get into example 1. So we're going to stop here with this video.